In this video, we're looking at the Newton's law of cooling. We're going to build a model for this, solve it, and then we'll apply it to a specific situation. So this general principle says that the temperature of an object changes at a rate proportional to the difference between its temperature and that of its surroundings. To get started, we're going to parse this relationship, giving names to the different pieces that we're going to be looking at. So let's give a name for the temperature of our object. So just so that we don't have confusion between upper and lower cases, I'm just going to call S of t the temperature of our object at time t. We're going to call the room temperature. Let's maybe call this T naught. This is going to be our room temperature. And we're going to assume that this is stable throughout. All right. So let's see. So it says that our rate of change of temperature, so that's ds dt, is going to be proportional to the difference between our object's temperature and its surroundings. Okay, so what that means is that if we're looking at S minus T naught, that's our object's temperature, minus the room temperature, that we expect this to be proportional. And so proportional means that there's just going to be a constant multiple difference. And because we know if our object is hotter than room temperature, we expect to see decreasing temperature of our object. So we want a negative rate of change. And if we see a colder object, we expect it to be warming. So we expect a positive rate of change. So we're going to use a negative K to say we want to go in this opposite direction, where K is going to be a constant greater than 0. Okay. We also have an initial temperature of our object. So I'm going to say S at time T dot is equal to, we'll call it S dot, our initial temperature. All right, folks, so we have our initial value problem. Notice there are some constants going on in here. Our next step is going to be to solve them.